Hello and welcome back to my channel. Students, as you all know, we are doing a problem series where we have already completed 12 problems. We are currently doing a topic from organic chemistry, that is general organic chemistry, and we have already taken up a few topics like resonating structures, aromatic behavior, carbocations, carbene ions, acidity and basicity. So let us try to see what is there in our problem number 13. Student, as you all can see, we have a compound in front of you, and in this compound we have 4 hydrogens marked as A, B, C and D. So you can see there are 4 hydrogens, and you have to assess these hydrogen. You have to think about these hydrogen in terms of their acidic strength, in terms of their tendency to go away as H plus. Okay, so I have already dealt a few problems like this. In such type of problems, you have to take the H plus out of the compound, the substrate, one by one, and as you take the H plus out, there will be a conjugate base left behind. The atom from where the hydrogen was attached will get a minus charge, and I have already told you the inception of charges, the bearance of charges is a symbol of instability, and as you take away a proton from the carbon or from an atom where it is attached, it leaves a negative charge on that atom, and you have to look for its stability. And I have told you there are certain important tools which take care of that charge, that negative charge, like resonance effect, like inductive effect, S character, etc. So we will keep on taking the hydrogens out one by one, and we'll see the stability of the anion which is formed. So first of all, I am going to take away the hydrogen number A. Okay, so we are now going to take away the hydrogen number A, and as you can see, the moment you have taken out the hydrogen number A, the carbon from where it was attached earlier now gets a minus charge. Now you have to see whether this minus charge is stabilized or not, because you have to take care of this minus charge for the hydrogen to get removed easily. For higher acidity, the anion formed must be stable. So as you see the possibility, you find a conjugation. How? Minus, single, double. Either you go this way or that way, minus, single, double. So you find a certain part like this being cyclic in nature, it's a flat portion, and there is a cyclic conjugation, as you may have observed. Minus charge, single bond, double bond, all the 3 carbons are involved in this conjugation song. So you see, and how many electrons are involved? If you try to find the number of electrons, 2 electrons from here and 2 from this pi bond. So altogether there are 4 pi electrons in a ring. Now as soon as you get this figure, it alarms you. It alarms you about what? It alarms you about an important feature which is called as anti-aromatic behavior, anti-aromaticity. You know, if there is a cycle, the cycle is planar, there is a cyclic conjugation, and the total number of electrons involved in cyclic conjugation, if it follows 4n rule, where n can be 1, 2, 3 and so on, so you will get the number 4, 8, 12, etc. Then that part of the system becomes anti-aromatic in character, and as I have already mentioned several times, aromatic aromaticity gives stability, and on the other hand, anti-aromaticity makes you that unstable. So the moment you have taken the hydrogen out, you have got an anion, and that anion is not a stable one. Why? Because it gives anti-aromaticity to the system, which is not good for the health of this carbene ion, this anion. So the hydrogen will not go away with that much inclination, with that much tendency, and therefore the acidity will be lesser. So that is how you have to diagnose the things. Now coming on to, we will now take up the hydrogen number B in the next slide. As you take away the hydrogen number B, the carbon from where the hydrogen was attached will get a minus charge, and then you have to see whether it is stabilized or not. Then you find that there is a possibility of resonance, because you can see a conjugation minus, single, double. And because of this conjugation, you can delocalize this minus charge like this. You can float these electrons to make a new pi bond, and simultaneously these pi electrons are going to sit on this carbon, and this carbon then will get a lone pair with a minus formal charge. So I have made the structure after the resonance has happened. As you can see, a new pi bond will arrive, and now this carbon will get the lone pair along with a minus formal charge. So you can see that the removal of B gives an anion that is stabilized by two resonating structure. Okay, there is a fair bit of delocalization which should happen for the anion to be stabilized. Okay, now we will see what happens if we remove the hydrogen number C. You can see now this is our hydrogen number C. Now I am going to remove this hydrogen number C in the next slide. As you can see, okay, I think this is C. Okay, now you can see in the slide I have removed the hydrogen which was mentioned as C. As soon as you remove this hydrogen, a minus charge comes, and this minus charge, you can simply see that makes a very important behavior. It creates a very important behavior. How? You see, minus, single, double, single, double. So there is a cyclic part, a flat part, where a cyclic conjugation you can see minus, single, double, single, double. So this cyclic conjugation, this song has included all the 5 carbons of this ring. And if you try to count the total number of electrons which are involved in this cyclic conjugation, you can count 2 from here and 2 from there. So how many? 6 pi electron. And as you all know from Huckel's rule, 4n plus 2 pi rule, if you take n is equal to 1, it gives you value 6. So from this you can confirm that it follows the Huckel's rule. There are 6 pi electrons in cyclic conjugation. So it gives an aromatic character to this anion. So in the previous slide, as you can see in this particular slide, when I removed the hydrogen number A, you got a ring which was anti-aromatic in character. However, in this particular case, the hydrogen number C, after the removal of hydrogen, you are getting now an aromatic character to the system, and that is a very superior character, you should understand. And since it makes the anion much stabler, so hydrogen is now, it can now go away with more tendency, because it knows that after it goes away, the carbene ion can take care of itself. Why? Because it will have the aromatic help, it will have the aromatic behavior. So C is a stable anion. Okay, now we are going to next remove the hydrogen number D in our next slide. So as you can see, I have removed the hydrogen number D, and as it is removed, a minus charge comes to this carbon. Now as soon as it comes, you should think about its stabilization. Then you find that it is in conjugation. How? Minus, single, double. So you can delocalize these electrons one position ahead, and these pi electrons will sit on this carbon to bring a lone pair and a minus formal charge. So from here you get this particular resonating structure. As you can see, a new pi bond has been created, and this carbon has got a lone pair and minus formal charge. Now again you see there is a possibility. How? You see, minus, single, double. So you can get these electron flown one position ahead. These pi electron are going to sit over this oxygen, and this oxygen is going to get a lone pair and a minus charge, and as you can understand, a new pi bond has been created. After this has happened, what I have tried to show you in the next resonating structure is there is a possibility of getting an aromatic resonating structure, a resonating structure with a benzene ring. How? You understand, after you have made the second last resonating structure, that is this resonating structure, you can see that there is a conjugation double, single, double in the upper ring. So there is a conjugation and the resonance will happen. In that case, how the resonating structures you are going to draw is like this. You shift these pi electron like this, and these pi electrons are going to sit on this particular carbon. You could have done the other way also, the opposite way also. Now as you do this, this carbon is going to lose the electron and will get a positive charge. This carbon is going to get the electrons in the form of a lone pair and therefore a negative charge, and a new pi bond is going to be developed between these two carbons. And as it happens, you understand, it acquires, this particular anion acquires a benzene ring and it gives an aromatic character. You should understand, the upper ring now plays a part. There were two pi bonds which were in conjugation, and there will happen resonance between those two, and as it happens, it creates a pi bond here which completes one benzene ring in this system, and that gives an aromatic character to this anion. Now you should understand, this anion has somehow developed an aromatic character. In the case C, you saw that the aromatic character was created by this cycle. Now if you are going to see the C and D, the aromatic resonating structures, what difference you find? The difference I find is, and you will also appreciate that, in the resonating structure belonging to C, there was a single minus charge, and that will create an aromatic ring. Only one formal charge, and you should understand the creation of formal charges, the plus charges, the minus charges. More you create these type of charges, more will be the instability going into the system, because it's not good for the health of any structure to have more plus, more minus. Okay, it is bad. Okay. Now, if you see the C option, you have just one minus charge. On the other hand, if you see the D aromatic resonating structure, the structure having an aromatic benzene ring, you find apart from one minus charge which it had, all the previous structures all had single minus charge. But in the final structure, for the sake of commencement of aromatic behavior, for the sake of bringing aromaticity, you have to make a sacrifice. What sacrifice you have to make? You have to create extra formal charges. You understand? Apart from this minus charge, you have to create one more plus charge, one more minus charge. and then the aromatic behavior will come. So I am not saying aromatic behavior is a bad thing, but this aromatic behavior is not just coming because of the delocalization of that single negative charge. You have to create more charges in order to bring this benzene ring into the system. So if you compare the aromatic behavior, the benefit you get from the aromaticity in C and in D, you will find that C was a better option. Why? Because you did not have to create more formal charges, just the same minus charge which created due to the loss of proton, when gets delocalized in the ring, it creates the aromaticity. However, in the D option, you had to create more formal charges, then you got the benzene ring in the system. So taking all these features into account, I have finally in the final slide taken all the pros and cons, and as you can recapitulate the things we have done. So after removal of the hydrogen number A, I told the minus charge will come here and you get an anti-aromaticity in this part of the system, which is not good for the health of the anion. It is very bad thing, anti-aromaticity. Now, in the case B, the minus charge came this position, and you saw you got two resonating structure, one this itself and the next one minus single double, and the minus will come this position. After the removal of C, you got something very sacred that is called as aromatic behavior. So it was a boon to that anion. It was good for the stability of anion, because aromatic behavior is a very good thing. However, in the case of D, you tried to bring the aromatic character, but that came at the expense of creating more formal charges, which is bad for the health of anion. So although you got some benefit of aromaticity, you had a loss also because of creation of more formal charges. On the other hand, in the case C, you did not have to create more formal charges, and the single minus charge will bring that boon to that system, will bring that stability to the system. So if you take everything into account, so you can say the removal of D, although brings aromaticity, it is very feeble, okay, although it will have some aromatic character. So taking everything, the pros and cons, into your consideration, you can finally say that the removal of C is going to be with most inclination, most tendency, followed by D, and then will come the B, and the least is going to be A. Why? Because A was anti-aromatic in character, making the things highly unstable, okay. So that is how we have to dissect the concepts, the fundamentals, and we'll have to see how the resultant conjugate base, how the resultant anion behaves, whether there is a possibility of resonance or not, and if at all, we have to remain very cautious that resonating structures, those resonating structures should not make it anti-aromatic, because resonance can stabilize, most of the time it stabilizes, but in the case where it creates anti-aromaticity, it destabilizes, and the same thing is happening in the case of A. So we should remain very cautious these type of situations. So I hope you all must be getting the points I am trying to convey, and similar type of questions, similar concepts and much more are still going to come in your future problems, and we'll try to include all those. Till then, take a good care of yourself. Thank you very much.